Sir, you are not audible properly.
Hello, good morning. Am I audible now?
Yes, sir. Good morning.
Uh, Now, in the last class, uh, we have introduced to all the system tracks, and we also showed those system tracks in the perspective of a entire sequence stratigraphic model, which is actually a revised exon sequence stratigraphic model. So the last diagram, what I had drawn, that is an attempt of showing how the system tracks they are mutually interrelated to one another in the entire basin filling history. Suppose when you start with the unconformity and then you get a polyp stage system track in the form of a submarine fan, which is overlying a correlative conformity of a unconformity. If you can open your drawing of last class, you can see what really is happening is that with a type 1 unconformity, that is developing in the proximal part of the basin, you are actually a diachronous with development of a diachronous subaerial unconformity. The river is incising and it is creating a submarine fan in the distal part of the basin in the form of a over the correlative conformity. That is what is shown in the basal part of the depositional sequence. So, why at all it was told earlier that a sequence stratigraphic concept has a predictive capability? What is the meaning of predictive capability? The meaning of predicting capability is that if I am working in the proximal part of the basin, if you open the diagram in front of you, somebody working in the proximal part of the basin, and he identified that there is a type 1 unconformity and which is incised by a fluvial system, then a natural corollary is that person will suggest to their company that we should explore to the distal part because a submarine fan can be hidden for us in the distal part. So that the proximal to distal relationship, that when you have a subaerial type 1 unconformity with fluvial incision in the proximal part, the natural tendency is that you should expect a submarine fan in the distal part. And as you know, that this distal part, that the rootless submarine fan in the base of the slope, they are in many cases some excellent hydrocarbon reservoir in form of the stratigraphic tract because they are overlying over the marine shell. marine shell, and they will be overlain by the marine with ensuing transgression. So some of these, that is what people refer to as a deep water reservoir. Deep water reservoir. That how the deep water reservoirs form. Am I clear? Am I clear, or is there any question here? Hello? Hello?
Yes, sir.
Is it clear what I am saying?
Yes, sir.
Yeah. Then what you are getting, that once that subaerial unconformity, because that at that time you are actually working in the falling base level, and all along this falling base level your unconformity is falling. All along this unconformity is falling because continuously the base level is falling, and that unconformity we are basically talking about. Now the sea level will be rising slowly. So what you are getting, if you open that diagram again, you are getting the low stand delta and low stand weight. Low stand delta and low stand weight. We will be coming to that. That what is a low stand weight, what is a low stand delta, and how really we identify it as a, because that is a time of normal. What we discussed earlier, this is a time of normal regression. Normal regression. And that we basically refer to as the low stand. So this is your falling stage. So that we will be talking about, that the normal regression and low stand. That is, we will be talking about what really happens at that time. What really happens at that time, and what are the different possibilities of that. That we will be discussing today. Now, after this, you have the transgressive system transgression. So during the translation, you have seen, if you again go back to that diagram, that continuously there is a retrogradation that has been shown, that the basis wave is actually tracking back towards the land. If you remember, if you see that figure very carefully, that all in different time slices, the basis wave is moving towards land, and that shows that there is an onlap on the proximal part, and there is a downlap in the distal part. You can see that how really is the strata. Even when you go to the seismic, you will be seeing this stratal relationship, that there is an onlap and a downlap, and that you basically match. That is and the topmost part is that when you have the most significant, that strata which is basically covering from proximal to the most distal part, what we are referring to as the maximum flooding surface. So the top of this is the top of it is the MFS. MFS, maximum flooding surface. You can see that the tracking back of the basis bed, tracking back of the basis bed. So how you will be basically getting is all the fining upward sequences. Fining upward sequences, and that will be basically, because anywhere if you make a vertical log in that figure, that will be giving you a fining upward sequence. And that fining upward sequence, which the individual unit, somebody asked me that day that what is the parasequence? Actually, if you see that the total TST is divided into several units, and each unit is showing a retrogradational tendency, that each fining upward unit is actually referred to as a parasequence. So when within a system track, a particular unit, the unit of the basis belt, that is a parasequence. We will come back to parasequence in more detail afterwards. Then you have a maximum flooding, and that maximum flooding is overlain by till again all counts. This is overlain by the high stand system tap. So again high stand system tap, this is again a normal regression. Again a normal regression, which is a high stand system tap. Now how this normal regression of low stand and normal regression of high stand, how will be identified? It is a low stand normal regression, or it is a high stand normal regression. What are the criteria? How the stratal stacking pattern that differ between the two? all these, what will happen in this case, in this case, in this case, and this case in the shoreline, that we will be basically talking now. The different ifs. So, if I get a coastline, suppose I am thinking of a coastline, okay? That coastline, that how will be the stratal stacking pattern or in a coastline in different tendency of relative sea level. We are now talking about the relative sea level. Relative sea level falling, relative sea level slowly rising, relative sea level fastly rising, relative sea level and slowly rising. So all these that basically what will be the pattern at the coastline in terms of the stratal stacking. We are now talking about a cross section of the coastline. Cross section of the coastline. So what we will be now talking about? The cross section of coastline. Cross section of coastline. And how that cross section that will talk me that what relative sea level stand I am in. Am I clear? What cross section of the coastline will tell me at what relative sea level I am in. That I will be discussing now. One minute. I'm not able to draw it properly. Let me draw it first. then I am explaining. Please let me know when the drawing is complete.
So the down building, is it in the diagram or is it for 0 to minus 90 degree?
Which one?
So the down building.
Hmm. This one, minus 90 degrees.
So it is for the diagram.
Right, yeah. Which one?
So I'm saying the down building, it is in the diagram.
Yeah, this
Okay.
minus 90 degree, the rounding thing is for the diagram.
Okay, sir.
Done, sir.
Okay, so what we are trying to tell you here? We are trying to tell you that different kind of stratal architecture, what we expect at different rate of relative sea level change. And then how you identify that what I am basically seeing either in a seismic section or in an outcome. Suppose this is 0. So what your coastline, that is the coastline, that is the big point, what it is showing? It is showing a steady and steady regression. There is regression. There is regression because you have the progression that is going on. So there is regression, but the regression is very steady. Regression is very steady. The reason is that the water level that is not rising, that is not rising. It is steady, and the accommodation that is available, that is getting filled by the sediment supply. So the wind point of the profile, the shoreline profile, the coastline profile, that will remain at the same level, and you will get the steady growth. You will get the steady growth without any change in the profile. Now you come to this 0 to 90. 0 to 90. Now this is actually one example that is being shown, which is actually ascending regress. We call it ascending regress. Ascending, which is actually a signature of the normal regression. Normal regression. Okay? It is the steady state regression. This is the normal regression. We call it ascending regress. Ascending regress, because the beam point of the profile, it is actually migrating upward, but at very low angle, less than 90 degree. It will be ascending at an angle less than 90 degree. Less than 90 degree. So that less than 90 degree, you call it ascending regressive, and that is a character of the normal regressive. Now why it is ascending regressive? Because in this case actually the accommodation is not increasing, but in this case accommodation is increasing. Accommodation is increasing because relative sea level that is rising, but rising at a very slow rate, but that is creating an increase in the accommodation, and that is why the big point, it is uprising, indicating increase in the accommodation, but that increase is less than 90 degree. So it is less than that. Now what it will result? What it will result? It will be initially resulting the aggradation followed by progradation. That will be resulted. But here you will be having an ascending regress. Now you come to 90 degree. 90 degree means that the sea level is vertically rising. That is rising, and that will cause the pure upbuilding. That is called the pure upbuilding. Here what it was doing? It was an angular building. It is ascending on in this direction, so it is building angular, but in 90 degree it is building vertical. Now you come to 90 to 180. 90 to 180. So there is a rise which is more than 90 degree. More than 90 degree. So you can see that this is the direction of the rise, and this is when you get the transgression. This is transgression where you have a rise which is, this is 90 degree, this is 0, this is 90 degree, and this is this. So it is more than 90 degree. It is about 120 degree, and you have the beam point, that is, this is 1 and this is 2, beam point migrating this side. So that is what you are getting, the transgression. Now what is happening in post regression? Post regression we call it descending regress. This is ascending regressive. This is descending regressive. So I am drawing. This drawing is difficult. Okay. So this is 1 and 2. This is 1 and 2. So your breakpoint, it is going down. It is descending regressive. Either you take this or we take this. So that is actually the descending regressive that you are getting in case of the forced regression. So if I in a comprehensive diagram, if you see that there are different kinds of the shoreline trajectory, and that different kind of shoreline trajectory that will result in the different stratal stacking pattern, and that is actually the case when you are getting the ascending regressive, descending regressive, steady state, then upbuilding, or it is the more than 90 degrees, the tracking back of the shoreline. That is a comprehensive way that is being shown that how the coastline and the cross section of the coastline that varies at the different relative sea level stand. Is it clear? Any question here?
No, sir.
Okay. Now we'll come to individually. Individually to different case. First start with the translation. What happens in the translation? Have you got any book of sequence stratigraphy?
No, sir.
Hmm?
No, sir.
So कैसे पढ़ाई कैसे करोगे? लाइब्रेरी तो खुल रहा है. और नहीं तो ऐसा करते हैं, देखते हैं. I have a digital book. I may send you. Okay. Now translation. First, let us start with translation. Translation. What is happening? That here accommodation is increasing and sediment supply cannot match with the translation. So on the rise of the accommodation, then you are getting a translation. So there are two kinds of setting that I am talking about. Two kinds of setting. In one case, it is a shallow wave dominated coastline. And this will be steep dip, low dip. Another is river dominated coastline. Which are commonly steep dip. And what is river dominated coastline? Where you are getting the formation of delta. Getting the delta. Normally, what happens when you have a wave dominated coastline? and there is no river meeting there, no active the measure the sediment supply by the river, no delta is forming that part of the coastline. Normally, it is found to be 0.3 degree. That is the general gradient of the shore face or the coastline, shore face or the shallow marine gradient. Whereas if you go to the river dominated delta, in common case, the river dominated delta, there the slope of the coastline that goes almost up to 1 degree. In Gilbert type delta, that slope may go even up to 30 degree. Up to 30 degree. So you can understand that the difference between a wave dominated coastline and a river dominated coastline. In a wave dominated coastline, where it is more gentle and there is more wave. Okay, so the effect of transgression that will be different in both the cases, in the two cases. So first we start with a wave dominated coastline. Have you drawn it? Hello?
Yes, sir.
Have you drawn it?
Yes, sir.
Okay. So what we are discussing now? We are discussing now transgression. Okay. Now transgression, if you remember correctly, our relative sea level curve and the different stratigraphic surfaces, sequence stratigraphic surfaces, and the transgression. Transgression, what is the lower boundary of the transgressive system track? The lower boundary is the maximum regressive surface or transgressive surface, isn't it? Maximum regressive surface, that is the lower boundary of a TST, and the upper boundary is the maximum flooding surface. Am I clear? So if you
Yes, sir.
hello,
Yes, sir. Clear.
so the MRS and transgressive surface, they mark the lower boundary and MFS mark the upper boundary. Now, within this transgressive system track, how really the different type of coastline they behave. That is our. So we are dividing the coastline into two types. One, which is wave dominated, low gradient coastline. Normally, wave dominated, low gradient coastline, they are basically there we get a gradient of 0.3 degree. And what happens really in that, the wave always will try to make a equilibrium surface of the shoreline, because with the prevailing energy condition of the wave, in some coastline wave will be more energetic, somewhere wave is not so energetic. So different part of the coastline there is a different kind of energy of the wave. Wave, according to its own energy, it will always try to make the shoreline profile into a equilibrium surface. So it is the prevailing energy and the equilibrium with respect to that prevailing energy, what is the profile of the shoreline. Okay. Now we are getting a low gradient shoreline. So first diagram, that is basically showing us the shoreline which is a low gradient, and the wave is maintaining the gradient of this the wave is maintaining the equilibrium profile. Wave is maintaining the equilibrium profile. Now I have a transgression. So when I have a transgression, so this is 1 and this is 2. So now the transgressive profile is this. Now as the transgression happened, then the entire profile got disturbed, because earlier for the profile 1, the prevailing wave condition, the profile 1, the prevailing wave condition, that is maintaining a equilibrium profile. But now as you have a transgression, the entire profile gets changed. Now again the wave it will try to establish its equilibrium. So what it will do? It will try to erode. And the eroded material that will be deposited in the lower intertidal part. So if I divide this coastline into the subtidal, intertidal, and supratidal, these three different subdivisions it will do. Okay, so what will happen? The supratidal and intertidal part, that will be wave reworked, and that sediment will be deposited in the lower intertidal or subtidal part. That will change. So what will happen? That this was the original type 1. That was the profile. The next profile now it becomes like this by means of deposition of this material, which is eroded from here, yeah, and deposited here. Am I clear? This is called healing phase deposit. This is called healing phase deposit, which is associated with transgression. So the wave is eroding it and depositing the material in the lower intertidal or subtidal part, calling it a healing phase deposit and changing the entire equilibrium profile of the coastline. So when finally after this the new coastline will form, the new coastline will be like this. New coastline will be like this. Now this portion is wave eroded, but this portion is depositional. This is also the aggregate. So how you will be getting this? You are getting this is a aggregating, no question of erosion here. Then as you come to the shallow marine part, you get a erosional surface. But again, you are when going to the deeper part, that erosional surface gone. It is again a depositional surface. You see the beauty that the intermediate between this proximal and the distal, you have a erosional surface, and that is because the establishment of the new equilibrium profile along with the transgression. Am I clear?
Yes, sir.
Yeah. Now, this is when it is a gentle gradient. Now we are getting a steeper gradient. Now you have a steeper gradient. So there is a steeper gradient, and in this steeper gradient, you are again getting a transgression. So what will happen in this steeper gradient? I will also show that what happens to a fluvial system. We will discuss that there will be a fluvial erosion, there will be a coastal erosion, and there will be a marine erosion. So you have that the coastal erosion. This coastal erosion was not there. This coastal erosion will only happen when you have a steep gradient in the proximal part, in the fluvial part, in the shallow the proximal part. You have a steep gradient. Then there will be we get the formation of the coastal cliffs. Coastal cliffs. These coastal cliffs, they are basically formed during transgression when the proximal part they are the steep dipping. They are steep dipping. That will not happen when you have a. So then you have a coastal erosion, fluvial erosion, and marine erosion. So then the surface that will come like this. That will come like this. Okay. Healing phase deposit कैसे फॉर्म करता है? Is it clear? What is called healing phase deposit? And when the healing phase deposit forms, I think it is clear to you now. And why at all it is forming? What will be the character of the healing phase deposit? There will be completely wave reward deposit. Wave reward deposit, and I will get that in the deeper intertidal part, and that will be correlatable to the transgressive coastline. In case of transgression, if I get a, so what will be the character? It will be a wave reward deposit in the deeper intertidal to subtidal part, which will not have a erosional lower boundary. A depositional lower boundary, there will be no evidence of erosion at its base. This is a simplistic diagram which is showing that how really with respect to the underlying Loscan system tract and overlying MFS, the transgressive system tract that you are developing. Okay? Are you understanding what I am saying? Till now, what I have shown you that in a low gradient coastline and a high gradient coastline, how the different agency that will be responsible for the erosion of the shallow part and the deposition in the deeper part. And there will be aggradation in the most proximal part. Okay. Now that knowledge is being shown here in a perspective. How? This is a LST. This LST, this is on this side, it is truncation, erosion and damage. And this side, it is downland. Okay. Now, this was the regression. So LST, as I have said, it will be ascending regressive. I will be saying ascending regressive. So there is a correlation. So now this LST, this is a regression. This is the topmost surface of the regression. Topmost surface of the regression. Okay. So there is topmost surface of the regression. Above that, so the LST, that is so this is the MRS. That surface is here, topmost surface of regression. After this, the transgression starts. So the on-lap starts. Transgression starts. So the on-lap starts. Fine. Now this is the deeper part. This is in the deeper part, and we are getting. Now, what is happening in the shallower part? I said that the wave that will try to re-establish. So what that will do? That will continuously erode. That will erode. So the transgressive product will be very thin here. It will be represented by a lag deposit. What we call the transgressive lag. What we call the transgressive lag. So you are getting, so in the deeper part, you are getting the healing phase deposit. They were showing a depositional trend at on lap, but then there will be a huge surface that will be the represented by the transgressive lag because of the establishment of the wave equilibrium surface, as I have already discussed earlier. So you will be marked by the transgressive lag, and then again when you are in the proximal side, the same. So this portion, the entire transgression, they will be basically very condensed, and they will be marked by a lag surface which will be overlying the low stand deposit. So because it is erosion, so you are getting the entire low stand that is marked at the top as the truncation. So it is truncating. So why it is truncating? Though there is a transgression, though there is an increase in the accommodation, there should not be any transgression. There should not be any transgression. But yes, there is transgression even in the there is erosion even in the transgression because of the establishment of the wave equilibrium surface. Now, when you come to the proximal part, then again this erosion that the wave equilibrium surface, the necessity has gone. So here again you are getting the depression. Suppose the estuary is forming, the river valley is getting drowned, and then the agglomeration that is there, which is at the top of it will be the elements. And above that is the ice cap. I am not discussing here. This is another we will discuss setup. So is it clear now that what I am talking about as a transgression? हेलो, ट्रांसलेशन लेके किसी का कोई क्वेश्चन है?
In the healing phase deposit, we will have erosional base.
Yeah. See, what I have discussed, if you remember my earlier diagrams, what I said that when you have a transgression, you are disturbing the wave equilibrium surface. Okay? And not only transgression, I will show you even during the regression how we disturb the wave equilibrium surface. Regression may be different. Now I am discussing the transgression. In transgression, I am disturbing the wave equilibrium surface, and then wave will be operating to maintain its equilibrium surface, and they will erode it. And the eroded material will be deposited in the distal part of the basin as a healing deposit. That same logic I am applying in this diagram. Here in the perspective, it is shown, it is not only the transgressive perspective, I am taking a perspective from its earlier low stand deposit, and above that how I will be expecting a transgressive deposit to be formed. Okay, that perspective I am showing. So नीचे जो है वो LST दिखाया गया। LST के ऊपर entire transgressive product कैसे आए? How the entire transgressive product with its basal surface and with its top surface, as I discussed, that there is MRS at the base and MFS at the top. So bringing the MRS and MFS, how the transgressive surface and its products that will come onto the low stand system that is being shown in this diagram. So what I have shown here in this diagram, that the LST ends here with the maximum regressive surface, and the entire stacking pattern that gets changed as on this side of the MRS and on this side of the MRS. So now in this side you are getting the overlapping pattern, which is the indicator of increase in the accommodation. Now this indicator pattern, so you have a deposit here, There is no problem. So all the tendency of the transgressive system trap, I will be identifying here. The finding of character, the finding of sequences. So all these things you will be getting here. But as you are approaching here to the shadowing part, so what you are getting here, that you are getting the wave is trying to maintain its wave equilibrium. So wave is continuously getting reworking and eroding and depositing the material in the deeper part. So what will be left here? The processed material which wave could not carry, that will be left behind as a sheet here, which is with the erosion of the lower LST, a granular sheet that will be forming here, which is called the transgressive lag. What we call the transgressive lag. What is transgressive lag? During the time of transgression, the wave reworking or the transgressive reworking of the underlying deposit, which actually caused but the wave could not carry the process of the material. That process of the material that get accumulated as a thin sheet erosionally above the underlying LST, that is what we call a transgressive lag, which is actually a sandwich product of the entire transgressive history. Because the other sediment, the finer sediment wave has taken away into the deeper part. Coarsest sediment it could not carry, so it has left behind. That coarsest material make a thin winner on the surface of the LST, and that is and it represents the transgressive lag. But again, when you come to the more proximal part, then the question of the wave equilibrium surface is not there, as you can see in the earlier diagram also. So you can have a transgression, it can develop a estuary, it can develop the aggradation. So that aggradation and estuary that can be. So here and here, I am getting the product of transgression. In between, I am getting a transgressive lag. Okay, it is all because of the earlier diagram which I have already discussed with you. Is it okay?
Yes, sir.
थोड़ा सा ना ये डायग्राम लेके अपना सोचा करो. It is not that I am discussing in the class, तो पूरा समझ में आए, थोड़ा सा visualize करने का कोशिश करो. Then it is not very easy. It is not very easy to, though I am drawing and looks very easy, it is not at all easy to understand that how it forms and how I will be identifying in the seismic, in the outcrop, and the peak. It is very easy in the board, but extremely difficult to practice actually. But unless you practice that, you will not be a successful geologist in the oil industry. Okay. Now I will come on to normal regression. Now we come to normal regression. Now in a sea level curve, where you get the normal regression? I get the normal regression here. I get the normal regression. In one case, the normal regression, it follows the falling stage and it is topped by TS. In other case, the normal regression, it is above the TST and it is followed by falling sequence. Okay. So there are one normal regression, second normal regression. One normal regression, it is actually succeeding the falling. Another normal regression, it is succeeded by falling. Am I clear?
Yes, sir.
Yes, sir.
Okay. So what will be the base of this normal regression? This one normal regression one, the base will be subaerial unconformity or correlative conformity. So this is correlative conformity, and the entire this part is subaerial unconformity. So this normal regression is followed by subaerial unconformity or correlative conformity. This surface is correlative conformity, and entire poly this is the subaerial. Okay. Now, which is topped by MRS and topped by MFS, and this is flowed by MFS and topped by basal surface of post regression BSFR or RSA, regressive surface of regression, topped by BSFR. So two different. So the diagram I had drawn earlier, I said the normal regression, it is the ascending regression. I told it is an ascending regression. Ascending regression. So that will be true for both this normal regression and that normal regression. In both the cases, there will be ascending regression. Then how I will be identifying which one is the product of normal regression 1 and which is the product of, because I do not have, suppose at some place I am not getting, so interpretation that whether I am seeing a normal regression 1 or normal regression 2, it is completely depending on its association, what is underlying it, what is overlying it. If I do not have the underlying and overlying, then how I will know that whether I am seeing the normal regression 1 or normal regression 2? You got my point?
Yes, sir.
Basically, both are normal regression, and we have discussed that the normal regression has ascending regressive, where the sea level is rising slowly and the sedimentation outpacing the relative the accumulation increase. Now, but whether I am in normal regression 1 or normal regression 2, that will be completely depending on its association. What is underlying it, what is overlying. Now, in absence of underlying and overlying, what criteria I will be following? Right. Let us see. you drawn it?
Yes, sir.
Okay. So this is NR1 and this is NR2. What is happening? In both the cases, it is ascending regress. Ascending regress. Okay? It is ascending regress. But in one case, the profile is concave up. Concave up. In another case, profile is convex up. Now, what is the meaning of this concave up? That is the normal regression related with low stand. And what is this convex up? This is the normal regression related to high stand. So how I will be getting here? Here the packaging pattern will be initial progression, later acceleration. What will be pattern here? Initial acceleration, later progression. Ideally, when I very simplistically I draw, then I draw this is normal. This is normal regression. Okay, so this is a simplistic, very simplistic normal regression, where it is a regression with a ascending regressive trend, and that trend will be less than 90. Now I am dividing that very simplistic normal regressive trend. What was the trend in case of transgression? उसमें हम लोग क्या किए थे? हम लोग पीछे चले गए थे ट्रांसग्रेशन. So यहाँ वेब डिमार्किंग करा रहे और ट्रांसग्रेशन पीछे चले गए. Isn't it?
Yes, sir.
हाँ.
Yes, sir.
ट्रांसग्रेशन हम लोग पीछे चले गए थे. तो यहाँ वेब डिमार्किंग कराते यहाँ हीलिंग फेज डिपॉजिट करा. Now we are getting to normal regression, where at slow rate the base level is rising, but the sediment supply is high, which is outpacing the same sentence. I have repeated several times. Now I am dividing the two cases. One, the normal regression, which is actually above the falling stage, based by the subaerial unconformity or correlative conformity, topped by MRS. That normal regression, which is a low stand normal regression. I am saying in that case, I will be getting the profile which is concave. Profile concave. And that stacking pattern will be initially progression, then aggregation. You can see that this is more aggregation, this is more progression, this is aggregation. Later aggregation, initial progression. Initial aggregation, later progression. Initial aggregation, later progression. The convex arc, that is basically, so this will be succeeded by TST. This will be succeeded by TST. This will be succeeded by FSS. Now, if it is succeeded by TST, so the progradation, aggradation, and then it will be retrogradation. So TST will be retrogradation. Since it is succeeded by FSST, so aggradation, progradation, and that progradation will lead to the further fall. So you have a further fall. So it is stopped by a unconformity. This is stopped by a transgressive surface. You see the beauty. Both are normal regression. One is stopped by a transgressive surface. So the final lithology, the higher bathymetry environment, and so the initial progradation, then aggradation, and then you have a final blend lithology, higher bathymetry environment because of the transgression that is coming after that. Whereas the other one, that is, it is stopping the MFS, but then initial aggradation and then progradation, and then finally it will lead to a subaerial unconformity or any unconformity that shows that fall in the base level. Earlier NR1 was showing finally the rise in base level, NR2 is finally actually showing the fall in the base level. Is it clear? Anyone has any question here? Please make it clear right now. What is the difference between two normal regression? What is the general concept of normal regression? And how these two normal regression, they are differing from one another? Normally in sedimentology, लोग तो रिग्रेशन ट्रांसग्रेशन रिग्रेशन वही खत्म हो जाती है, ट्रांसग्रेशन एंड रिग्रेशन, बट रिग्रेशन नहीं खत्म हो जाती है. अभी रिग्रेशन में आ गया नॉर्मल रिग्रेशन, पोस्ट रिग्रेशन, फिर नॉर्मल रिग्रेशन में आ गया नॉर्मल रिग्रेशन 1, नॉर्मल रिग्रेशन 2. फिर दोनों नॉर्मल रिग्रेशन में क्या डिफरेंस है? नॉर्मली हम लोग क्या करते हैं, ट्रांसलेशन रिग्रेशन करके खत्म कर देते हैं. सो ट्रांसलेशन में क्या है, तो कोस्टलाइन आगे जा रहा है, रिग्रेशन में कोस्टलाइन पीछे जा रहा है, बस हो गया, कहानी खत्म. बट कहानी वहां खत्म थोड़ी होती है. ओके, is it okay?
Yes, sir.
Okay. Yes, yes. Please, anyone is asking anything?
Sir, if we see an unconformity surface on top of the sequence, so can we always say that it is normal regression?
Normal regression, if we have the top surface, that is not only that, you have all other characters of normal. Anything which is topped by the, I cannot say that anything which is topped by the unconformity, that is a normal regression. No, you have all the criteria, and then you have the indication that it is topped by unconformity. Then you have a normality. It is not a single criteria that define a particular system. There are multiple criteria. That multiple criteria is not very easy to do the thing. You have to identify that what is at the base of it, how the stacking pattern in it, what kind of environment that has been developed, and what is the surface topic that. So a multiple criteria, then people come to a conclusion that yes, we are basically seeing a normal regression related to high stand or related to low stand.
So then we will look for successive TST and FSST track for the.
Yeah. So all the products are there, but then again that Yes, you are right. That basically it is a association of the different system trap that allow us to identify that which system trap is product of what relative sea level stand. But then again, that when we are getting, suppose I am getting a normal regression, which is the normal regression 2 related to the high stand. Then we have to see that how the coastline is behaving. Is the coastline the stacking pattern that is initially aggregating, later prograding, or initially prograding, later aggregating? Then what is the stacking pattern? How it is behaving? Normally, what we see that the normal regression 2 related to the high stand that initially show a aggregating and later prograding, whereas a normal regression 1, which is related to the low stand, which initially shows the prograding, then the aggregating, and topped by the transgressive system. Right? Hello. Aditi, you are online? No. I'll check that if you don't have any book, yes. Acha, Aditi, do we have the soft copy of Catanu book? So they are not having any sequence stratigraphy group. So you have their group. We can send that soft copy of the Catanu book in their this thing group mail. So I requested Aditi. She will send in your group the Catanu, the Octavian Catanu sequence stratigraphy book. I think that the digital volume is with us. We will send it to you. Okay.
Okay, sir.
Okay, sir.
And please read it. Otherwise, it is a very difficult. Questions will be more difficult. समझने में डिफिकल्ट इसके ऊपर क्वेश्चन भी डिफिकल्ट होगा तो कैसे करोगे ठीक ना करना पड़ेगा okay we have discussed the transgression and normal regression I end it today here then the next topic what is left for us is the forced regression में क्या होता है that we will be discussing okay
Yes, sir.
Yes, sir. Okay, thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir. Bye.
Thank you, sir.
Thank you. Acha, I just have a question. Are you people enjoying this sequence stratigraphy?
Yes, sir.
Yes, sir.
Because why I am saying is there are a lot of jargons, lot of terms in this, and this understanding these jargons and terms and putting that in perspective, it is a challenge for not only you but us also. Us also. It is not very easy to remember all this. I am also actually I am not discussing all the terms. There are other terms also. Within trend surface, there are also within trend surface, but within trend surface, I will not discuss with you. There are a lot of within trend surface. I will discuss sequence stratigraphy up to certain level, not beyond that. Not beyond that.
And so, do we look for specific sedimentary structure for the particular system trap?
No, sedimentary structure nahi, but the environment. Not sedimentary structure, but the different kind of environment. Suppose a delta. When the delta forms, delta always forms in normal regression. Either it is a low stand delta or it is a high stand delta. Okay, delta forms all. What forms in the transgression? In transgression, you get the estuary, you get the receding beach, the coastal cliff. All these are products of transgression. What will be in the forced regression? Here the submarine fan, the incised channel, the incised valley, All these are product of the forced regression. So different units, it's also tied up the different kind of development of environment. But sedimentary structure, that is a product of a particular flow. A particular flow can operate, as we have discussed in sedimentology course, in any environment. Suppose a channel flow. I can have a channel flow in a delta, in a proximal delta part, in the inner delta part. I can have a channel even in the submarine fan. I can have some channel. I can have a channel in a fluvial system, and any channel that can develop a kind of the 2 and 3 dimensional wave form, the planar cup cross stratification, trough cross stratification, anything. So any sedimentary structure that basically talk about a particular depositional agent. But what I am actually referring to you, that your question is actually related to the different system that for the development of different sedimentary environment. Am I clear?
Yes, sir.
Sir,
Okay. Okay. Hello.
hello. So I was saying that can we not simply just tell by seeing whether it is concave up profile or convex up profile? Do we
No.
really need to look for?
No. No. रुचि, ये
Yes,
जो
sir.
कॉन्केव ऑफ कॉन्वेक्स ऑफ प्रोफाइल मैं डिस्कस कर रहा हूँ ना, ये आउटक्रॉप में आइडेंटिफाई करना ऑलमोस्ट इम्पॉसिबल है. ये आउटक्रॉप में
Okay.
आइडेंटिफाई हो ही नहीं पाती है. All these you can identify in the seismic profile. Seismic में जब all the reflectors and all the strata that is available, then you can identify the relation between different strata. When you go to the outcrop, there will be, it is a erosional remnant. All the strata will not be present. So how you will be identifying the relationship between the different strata? The concave up develop or या convex up, that is not possible. I don't think it is possible. मैं तो कभी देखा भी नहीं, मैं किया भी नहीं. But this is theoretical, and people have established that based on the seismic data. But this is a concept in the sequence stratigraphy.
Yes, sir. Okay, sir. Thank you, sir.